Hello Kin 516. Today we're going to be going over Cap 2, the pathways of lactate from skeletal muscle into our liver. First I wanted to clarify the difference between lactic acid and lactate. Lactic acid, pictured, is an acid formed during anaerobic glycolysis that inside our body it quickly dissociates and releases a hydrogen ion. Lactate, on the other hand, is the remaining compound that binds with a positively charged sodium or potassium ion, and then it forms that lactate. You might remember a little bit about this when we did Cap 1, going over glycolysis. Lactate is formed during strenuous physical activity, typically when energy demands either exceed the oxygen supply and the respiratory chain cannot produce all of the hydrogen joined to the NADH. During rapid anaerobic glycolysis, NAD plus frees up or it regenerates when it pairs with excess non-oxidized hydrogens combined with pyruvate to form lactate. That's just explaining that process. The lactate pathway from skeletal muscle to the liver is actually a pretty simple process. During anaerobic glycolysis, when that lactate is created from the original glucose molecule, it then enters the bloodstream and then enters into our liver. So the Cori cycle removes the lactate released from the active muscles, and then they use it to replenish the muscle glycogen inside the liver, or it will replenish the reserves and store it for later. The big question that we're analyzing today is if lactate can be used metabolically, and the answer is yes. Lactate is definitely considered first and foremost an immediate energy source within those active muscles, but it is also a contributor that augments energy reserves. So not only is it providing energy within those muscles, the ATP within those muscles, it's replenishing the stores within the liver. So lactate production is really incredibly important, especially during high intensity exercise when muscle glycogen is depleted. And lactate aerobic metabolism is incredibly important as an energy source. By having lactate replenish those stores within the liver, it allows your body to feed off of that during prolonged high intensity exercise. The consequences of lactate accumulation. There is a myth, a misconception about lactate, that it is metabolic waste, and it's been long associated with impaired performance. Oh, lactate is what causes muscle soreness. Increased lactate is what causes decreased performance. And that's it's a simple misconception. Lactate's actually incredibly valuable to athletes. It can be used as an energy substrate in both type 1 and type 2 skeletal muscle fibers. It helps serve as an immediate energy source, and it helps serve as a stored energy source as well. And you can actually train up to that lactate threshold and train your body, and it'll actually enhance your body's oxidative capacity, and it'll improve your capacity as an athlete rather than hinder it, which is what the original thought was initially concerning lactate. So instead of it being this metabolic waste that causes you to get tired, worn down, and sore, it's actually an incredibly helpful thing that you can use, and you can track how well you are training your body past that lactate threshold to improve your performance. And all of this information can not only be found in our text, but in these sources. I'd appreciate any sort of feedback, and thank you for watching this video.